So now let's take a look at some of the most important parameters that you will be using with the guided simulation. So remember, for now we have just turned on the use guides. The rest is using the defaults. So I will turn this back. And one of the most important parameters that you will be using is the strength. And strength means the strength of the guide versus the simulation itself, or the forces that the simulation is using. So let me turn strength down to 0 and press play. And you'll notice we're back to the same result that we had before turning on the guides. Now, if we, on the other hand, go over the default of 1, say for example 2, and again play the animation, you'll notice how now the guide geometry will have much more effect on the pieces. So if we take a look here on the side, the pieces are traveling much more towards the right before starting to fall down. Now this is incorporating a very common problem when using guide geometry. And actually, let's bring it back to 1, which is the default. Again, press play. And even with the default, we had a few problems. So it's not very noticeable, but we have a few floating pieces, one large here and a few very small ones down here. And the first thing that you want to check to fix this problem is use guided neighbors. So again, I will bring back the strength to 2 just to make this more obvious. Press the animation again just to see where the problem is. So we'll usually have this problem here on the top. We have a lot of floating pieces. And what I'm going to do is turn on use guided neighbors. And let's see the difference. Okay, so it's a little bit better, but we can still do better than this. So first of all, let me change the bend animation so it starts from frame 0, just to make the preview faster. So it will start to bend, and here we have the floating pieces. So I'll go back to frame 1. And another very important parameter that actually goes hand in hand with use guided neighbors, if you go into the simulation settings, is this minimum neighbors, which defaults to 1. So what's this neighbors thing? So remember I mentioned that internally when you're using a guided simulation, the RBD bullet solver creates some sort of connections between these pieces that are inside the guide. So these connections are literally constraints that are breaking once there's enough stress on them. So what this attribute use guided neighbors will do is take a look if the neighboring connections or the neighboring constraints are broken, then the piece will be released and ignore the guides or start to be affected by the forces in the simulation rather than the guide. And this number of neighbors is just how much neighbors need to be broken before it is released. So let me increase the number of neighbors to 4, for example. Now let's press play. And now it will be easier for these pieces to fall down, because as soon as they find 4 neighbors broken, they will start to fall by themselves. So the higher this number is, the sooner these floating pieces will start to fall. So of course, if you go too high, you won't see the effect of the guide on the pieces. So it's a little bit of balancing here. I think for this case, we could go with 2 or 3. Just enough for the pieces to break off the main volume and then start falling. Another thing that you can do to change how the constraints conform is here under the setup, you will have a few parameters to create the actual constraints within the guide. So this works a little bit like the connect adjacent pieces. And if you take a look here, the max connections, it's only generating one connection between each piece. So you could increase this number of connections to create more lines, and this would yield a more flexible result. So take a look, especially here on this parapet. It will tend to flex more and to hold together a little bit more time before it breaks, which in this case, I think it looks better. The only thing is, the moment you start increasing these connections, again, you'll start having some floaty pieces. So you may have to go back and forth with these parameters. In this case, I will try to increase the number of neighbors. Again, to try to avoid the floating pieces. But in general, there's not much parameters that you can play with. I think with this, you can do much of the work. As usual, it's a matter of experimenting and practicing until you get the results you're looking for. So let's continue now with option 2. Let's create a small simulation with these boxes and then make that simulation drive the demolition of the building. So let me go back to my fractured geometry. So in this case, I'm talking about these boxes. And let's connect them to another RBD bullet solver. So again, we don't need any constraints. We'll just make them fall. So what I did was, just to avoid them falling all together, I created another RBD configure. And as we did in the last exercise, I animated the bounding box just to have them falling at different stages. So let's select the configure node, turn on the active, turn on the use bounds. And this time we will use the bounding box option. So you can press enter to be able to manipulate it here in the viewports. So I will create a keyframe with a box below the pieces. So in frame 0, I will alt click size and center. So let's press play. So since all of the pieces are outside the bounding box, they are inactive, which in this case, that's what we want. And then we will go to frame, say 96, and we will grow the bounding box until it covers the entire fractured geometry. So now if we press play, the pieces will start falling one by one. And this is looking good. So now let's connect this output. So we only need the low resolution output, the proxy, which is the third output, and connect it to the fifth input of our RBD bullet solver with the building. So now the guide will be this low resolution simulation. So let's go back to camera view and press play. So right now the animation is not working as expected, and the reason is I connected this proxy geometry output and we have no proxy geometry input, so we're only using the high resolution geometry, which in this case it's just a box, so it's fine. We can connect this first input. So let's template the simulation. So again, let's take a look at what's happening here. So let's template this low resolution sim and visualize the high resolution simulation. And this is more like it. we may need to tweak a few parameters to avoid this part of the floor falling down. So let's take a look. Let's decrease the minimum number of neighbors actually to 0. And this is working as we originally expected. So the RBD guided simulation is a very interesting new addition. I'm sure that you will find many creative ways to use it, but overall it gives you a nice layer of control of how the RBD simulation will work.